Okay, guys, welcome. I'm going to do a couple quick questions on your review for your test tonight. So here's a review for 2A. Highlighted a couple questions I want to make sure that I covered here. So it's 23, 24, and 30 on the first page that we're going to address. I want to talk about 23 because I see a common mistake a lot of times with this distributive of what looks to be a subtraction sign, but really we're hopefully starting to see it as a -1. So sometimes we miss this part. Sometimes students will make this just a -4 right here at the beginning. But what we have to do is make sure that we distribute to both terms inside. And so there's a couple things there that, like I said, sometimes get missed. So let's make sure we cover them. So this -1 becomes, times a 4 becomes a -4. -1 times a negative x, two negatives when they multiply and make it positive. So we get a positive x, and that's equal to 0. Let's go ahead and combine like terms. X's are going to become 2x. That leaves us with a -4 equals 0. Finally, we're going to start our reverse order of operations. And that's one of our main points for this, right? So inverse operation of adding 4 to both sides. So we're going to go ahead and scoot over here. So we're going to get 2x equals 4, divide by 2, inverse of multiplication there. Those divide into 1. 1 times x is just x, and so x is equal to 2. So that part wasn't the important part. I think the important part here was realizing what to do with that negative there. Not too different from what you would see on 22. Okay. So good thing we covered that. 24, I want to kind of talk about that one because that one sometimes includes, well, this one includes having one side turned to 0. Yeah, so this one has a equal to 0, so let's go ahead and see it. First thing we should do is combine like terms. Now we're noticing real quick that there's n's all over the place. And it's weird, it feels weird because there's nothing else besides n terms, so terms that can all be combined. Just start combining. It doesn't matter if you move the 6 over, if you move the 4 over, if you move the 2 over right away, or if you combine these. There is no wrong process with that. I'm going to go ahead and combine these personally because they're on the same side. So I get this. Sometimes this confuses students because you're not used to having n's on both sides. So I've seen students try to divide this -2 off. That was a common mistake I saw. You don't want to do that, right? Because you got to look at what you actually have here. I have terms of n and terms of n. I need to put those together. And the only way to put them together is if they're on the same side of the equation. So I'm probably going to move this n over here. This one on the left is -2n. I'm going to add it, right? Because when I add or do the inverse operation, it leaves one side of the equal sign and it goes to the other. So I'm going to add 2n to this side. I'm going to scoot this up here because I'm running out of room. So what does -2n and positive 2n make? It makes 0. And sometimes that weirds you out to have a 0 end up on there. But it's fine. So 2n plus 2n is 4n. And at this point, I'm going to go ahead and divide by 4. And anything divided by, or 0 divided by any number is always 0. So what we find out is that n is equal to 0 in this case. All right, so let's take a look at number 30. Number 30 is a fraction clearing one. I'd like to make sure that we kind of duplicate that process because it's one that's pretty good for us. Now, you could work with this and work with this 3/4 y and minus y, and you could put those together. It's not that terrible. However, it's a lot easier if we go ahead and multiply by a number that both the 4 and the 2 are divisible into so that they'll go away. In this case, 4 is probably the number that we're going to use. It's the smallest number that they'll both divide into. We have to multiply 4 to every piece then, right? We have to make sure that we don't do it just to the fractions, that it multiplies to everything there. So this 4 and this 4 here are going to reduce out to 1, right? They're going to reduce to 1, so it'll be 1 times 3y there, so or 3y, because it doesn't change it then. This is going to reduce out with this 4 here. That's going to turn into a multiplication of 2, because 4 divided by 2 is 2, so there's the 2. It's going to multiply by our y, so it's going to be a -2y. And 4, and this one has a 1 as a denominator, so it's not going to change anything, so 4 times 5 is 20. And so at this point, we should be able to solve this pretty quickly by combining just our two like terms there. So we find out that y is 20. And that was a lot easier problem that way than dealing with those fractions. Okay, so let's go ahead and take a look at a couple more on the bottom here. We'll switch down to the next page. Let's do a couple of these word problem ones. Make sure that we're on the same page with it. So we've got a bus traveling one. We've got a bus traveling at 40 miles per hour. We got a car traveling at 50. So right away, I'm going to start to think about those uniform motion. And then I've got to see, once I've got the idea of uniform motion in my head, so this is possible uniform motion, I need to think, well, is it going to be distance equals distance, or is it going to be distance plus distance equals some total distance that they're driving away from each other? So I have to figure out which one of those that I'm working with. So let's read through the rest of the problem and see if we can figure it out. So it tells us that the two buses are traveling the same distance. It says the bus one travels an hour later. 1 hour later than the car does. So the car leaves first, the other bus leaves an hour later. It says how many hours did each travel? So it doesn't really tell us which direction that they're going, but it does say that they travel the same distance. And then it says how many hours did each travel in the amount of time that the car left. So, all right, so to do this, I'm going to steal a spot up here at the top. I'm going to make a chart. I think this chart idea is really nice for this section of word problems because it helps us really organize our information. So here's our chart. We're going to say that there's a bus, and so we're going to label bus, and then there's a car. We're going to label the car. So now we've got to find all the pieces of information for it. Since we know it's a uniform motion, we know that we're going to be equal to some distance. So we're going to be looking for a rate and a time, and they're going to multiply, and they're going to be equal to our distance. And in this case, we're going to use this idea of same distance, which means that the distance of the car is going to be equal to the distance of the bus. So we will have a distance equal distance thing. We'll notice that we don't have anything. They don't talk about a total distance, so we'll be able to remove that one from our list. So now let's fill in our chart here so we can see if we can solve for this. So the bus then it gives us is 40 miles per hour, and I think it tells us the car is 50, so the car is traveling a little quicker. And then we got to see if we can sort out this time variable. And again, our goal here is to write one variable in terms of another. Okay, so we need to write one variable between these two things that they use. So it says that the bus travels 1 hour more than the car. Well, let's say the car then is our time, right? And the bus is going to be our time plus 1. So it's 1 hour more than the car. And so that's the variable time for the car, and then we adjusted it for the bus because we said it was 1 more than the car. So that's in one variable in terms of another. So the car gets a t, while the bus gets a t plus 1. So now we can go ahead and fill in our d equals d, because this is how we're going to write our function. And so our distance for the bus is will be 40 times t plus 1, and our car is going to be 50t. So now we're going to set them equal to each other and solve. So let's go ahead and fill that in. So I'll start with the car over here. 50t equals 40 times t plus 1. We're going to go ahead and distribute now. Make sure that we get that 40 to both parts. So 50t equals 40t plus 40. We start our solving process. So I'm going to subtract 40 from both sides. Oh, no, I'm not. I wouldn't want to subtract 40 because not that 40 anyway, this 40. We're going to subtract 40t from both sides because I need like terms on the same side. So those are going to turn to 0. And then I'm going to scoot up here and finish. So I'm going to get 50t minus 40t gives me 10t equals 40. And I'm going to divide by 10, isolating that t all by itself because that's my goal. Those turn into 1. And I get t is equal to 4. So 4 hours of travel for the car, because that's t, and then we add 1 hour for the bus. So the bus travels a total of 5 hours. At that point, we would put this into words, we'd write it out, but I'm going to keep moving because I want to keep this a short video. All right, the last one I'm going to talk about I think there's one last one. Nope, I got one more after this. This is a consecutive integer problem. This one says we've got 3, and in the consecutive integer problem, we know to start with our first integer and call it n. That's our first integer. And since they're consecutive, they go in order. So the benefit of being able to do these, and I haven't even read the whole question yet, is that I can say n plus 1 is my second integer, and n plus 2 is my third integer. Right? Because they're going to go in order. So I've got n plus 1, n plus 2. There's my 3 consecutive integers, so I just addressed this. They're going to add up or sum up to 66. So now all I'm going to do is take them. So there's my first integer, n, plus my next integer, n plus 1, plus my next integer, n plus 2, and they're going to be equal to 66. Oops, 66. And I'm going to go ahead and solve this pretty quickly. Those parentheses don't mean anything because it's a multiplication of 1 in front, so there's not going to change anything. So I get 3n. And 1 plus 2 is going to be 3. Sorry, I skipped a little step there because I want to keep this quick. I'll go ahead and subtract 3 on both sides. So I get 3n is equal to 63, which gives me 31. If I multiply that out, 21 most likely. So I find out that my first integer is 21, my second integer should be 22, and my third integer should be 23. So 21, 22, 23. And again, I'm not writing these out very well so far. All right, so the last one I'm going to do here is one of these literal equation ones or formula problems where you just have a bunch of variables and you're asked to rewrite it into something that fits a little bit better. So this one, they ask us to rewrite this equation. They give us this H equals equation. They said rewrite it for R, make it set up for R. So what we're going to do is solve and isolate that R right there, which means that we're going to do our solving process to it, right? Our reverse order of operations. So we're going to start by moving any additions. Well, let me forgot my first step, right? We need to clear it up first, then addition and subtraction, then multiplication and division. All right, so that's what we're going to do for our solving process for this. So if we look at this, we know that there's two things really done to R if we look kind of closely here. One, this set of parentheses, so this difference inside of here, this subtraction of these two variables here, are multiplied. That whole thing is multiplied to R, and then there's also a division of t to R. So I'm probably going to get rid of the parentheses here because it's kind of big, it's kind of glaring, and I say I want to move this out. So how do you get rid of a whole parentheses multiplied to it? Well, it's the same thing, right? Inverse operation. Doesn't matter how big or what it looks like, we're just going to do the inverse of it. So p minus m divided by p minus m turns into 1, so really it goes away on this side, so I'm going to do the same thing on the other side. So I'm going to divide by the quantity of p minus m. So I'm going to rewrite this because it's going to look a little funky so far. So h on the left divided by p minus m, and that's equal to r times t. So I'm almost done. I do need to get rid of this t, and its inverse operation in this case is going to be a multiplication of t. So I'm going to multiply by t on both sides. I'll scooch over here, and what I'm going to find, I'm going to use my equality property says that I can flip sides, so I'm going to put r first. So, and this t is a multiplication. We know that if we've got kind of two fractions here working, I'd hate to say it that way, but it is, right? T times h is th over the quantity of p minus m. So there's your R rewritten formula, literal equation. Okay, so there's a couple examples. One covers just about everything that we're going to see on the test. So hopefully if you guys need a quick look, this is there for you. All right, hopefully good luck on your test tomorrow. We'll see you then.